just going to run through a few slides as a general introduction, and then I'm going to hand the reins to Simon Minette from Shallock Energy, one of our members, who will give a brief introduction to industrial cogeneration, and then we will swing to the stories from industry. As you remember, this webinar is all about industry delivering the European Green Deal. The Green Deal, European Green Deal, is something that is taking up a lot of our time here in Brussels, and the industrial strategy was published last month. And Cogen Europe, as well as many different organizations, I'm sure, that are joining this webinar, are following the discussions and the evolutions of the strategy. And so today we have an opportunity to hear from industry themselves, two of Cogen Europe's members, one looking at the impact of toilet paper, and the other looking at green industrial processes and how they benefit local communities. So we have Solar Turbines presenting the toilet paper story case study, and then we have a speaker from Turboden as well. So just move on to my next slides. That was just an overview that I just presented to you. At the end of the webinar, my colleague François Paquet will give general conclusions and some remarks. But to be clear, like I said, questions can be done via the chat function. After the two guest speakers, we will open the floor for those questions, and Alexandra will come online and ask those questions to the different speakers. So a little bit about Cogen Europe. We are the cross-sectoral voice of the cogeneration industry here in Europe. Our primary focus is really to work with EU institutions, so the Commission, the Parliament, as well as the permanent representations and other key stakeholders to really shape better policies for cogeneration. Cogen Europe is a hybrid organization. We represent 12 different national associations from across Europe, as well as over 50 different corporate members. We're quite proud to say that we represent the entire value chain, so from the manufacturers, their supply chains, as well as from the megawatts all the way down to the kilowatts. In addition to that, we also represent the utilities, the ESCOs, and the end users. So I'm going to stop with this brief introduction and hand over the floor to Simon Minette to give a general introduction to cogeneration, in particular industrial cogeneration. Simon?
Okay, thanks, Hans. Good afternoon, good morning, everyone. It's a pleasure for me to introduce this first webinar on industrial cogeneration. So I'm going to start by, as we say in English, teaching grandmothers to suck eggs by telling you what you probably already know. What is cogeneration? So it is a technique that maximizes fuel use for combined output, so heat, electricity, sometimes cooling. It can use any fuel input. So it can use hydrogen, it can use natural gas, biogases, biomass, and ultimately it can use solar thermal as well. So it's a multi-fuel opportunity, and it provides heat and power to all sectors of the economy. Next slide, please. So the efficiency gains are well established, well known, and well proven in terms of the way that they are tracked and reported. So it's one of the few sectors, in fact, I think it may be the only sector that actually has full transparency of its efficiency. Most other sectors, it's more implied than given. So a well-installed cogeneration plant can save up to 40% primary energy. It will cut carbon emissions, and it will reduce the consumer's energy bills. And those three things are the raison d'etre for cogeneration. Next slide, please. So cogeneration is supported by many pieces of EU legislation. Sometimes they could be better, of course, which is what Cogen Europe's job is to ensure that we get an improvement. But it's especially apt for meeting the new challenges of the EU's energy systems. So it saves energy, as I've already mentioned. It cuts carbon dioxide emissions. It lowers energy costs, which is crucial for in this sector for global competitiveness of industry. It allows the integration of renewable energies. It provides flexibility across heat and power sectors. It avoids costly grid reinforcements. And I use a horrible jargon word, it is smart grid ready. The final point, though, is it empowers citizens and businesses to engage in the energy sector where without cogeneration, they're often just consumers of gas and power or whatever other fuels. Next slide, please. So there's been enormous focus over the last few years on CO2 emissions and the energy efficiency principle has been sort of downgraded a bit. But yeah, energy efficiency is vitally important in this process. Energy efficiency means you need less fuel to do the same activities. So cogeneration is a better use of input energy, whatever that input energy may be. It reduces costs and the need for imports of energy into the EU system. It provides greater security of supply, and ultimately it is the least cost efficient and most efficient way of delivering heat and electricity services. Next one slide, Hans, please. So focusing now on the industrial sector, many industries across Europe use cogeneration already. It is a substantial piece of the utility infrastructure for industries. It helps them face global competition. It is especially important where you have the need for high temperature heat and steam, and alternatives to that are either vastly more expensive or effectively technically impossible. And it allows industry to have that flexibility and a certain amount of insulation from fluctuating energy markets. So my final slide now was just to introduce the speakers again. So we have the two speakers, different case studies. So one on toilet paper and the other one on green industrial processes. And now I hand over to Mark Vignel from Solar Turbines to talk about the impact on the toilet paper industry, which, given the coronavirus aspects and the run on toilet paper, is a very apt subject for today's discussion.
Thank you, Simon. So, quick question: do I present the slides myself, Hans, or?
Yes, Thomas is about to give you presenter mode.
Okay, so share. You should be able to see my slides right about now.
Perfect.
Okay. So thank you, Simon, for the introduction. Thank you to Cogen Europe for enabling this outreach of information to members, participants, and invitees alike. My name is Marc Vignal. I'm the marketing manager for Solar Turbines based in Belgium. And well, we thought it very interesting to present a case on something very close to everybody's heart right now. As Simon mentioned, the run on toilet paper earlier in the year due to the pandemic makes it clear to us that it is something of essential need, and we're happy to present a case study to support this. Now, just as a matter of introduction, the energy landscape in Europe and in the world is changing very rapidly. We see companies rushing to stay ahead of regulation, sometimes even moving ahead of the said regulation. And we see some fantastic challenges being presented in terms of grid resiliency and basically the structural integrity of these grids with the deployment of renewable energy. Now, the public and society in general is looking to become more energy efficient. We're looking to reduce greenhouse gas emissions. We're trying to use alternative fuels like hydrogen or carbon neutral fuels like biogas and biomethane. And we're essentially trying to do more with less. We're trying to use resources more efficiently, and this presents a lot of interesting challenges. Now, in terms of the footprint, obviously, industry is trying to make its own impact. We see beverage companies moving to different type of packaging to cater to customers' needs. And we see the champions of the recycling and biomass industry, tissue manufacturers and pulp and paper industry, doing what they can to become less energy intensive. So as you know, an additional justification, and this is probably closer to some of our UK members' hearts, I wanted to share this one example that took place in August of last year in the UK. We saw two simultaneous events that completely crippled the grid in the UK, leaving users, leaving industry, leaving hospitals without any power because the one gas-fired power plant and one offshore wind farm shut down suddenly, causing a under-frequency in the grid, which essentially shut everything down. Obviously, in this day and age where hospitals are so critical, where distributed power is starting to become more attractive to users, we see this as an opportunity to present additional options to the industry for distributed power. Now, in terms of cogeneration and solar turbines in general, we are a manufacturer of industrial equipment for the oil and gas and power generation industries. We've got over 15,000 units installed worldwide, over 2,400 customers in the power generation industry alone. So we see a great benefit in the cogeneration industry to enforce that message of make more with less. Now, in terms of the new applications and the way that the industry is shifting, a significant part of our research and development budget is driven towards fuel flexibility and fuel optimization. So we're continuously trying to reduce greenhouse gas emissions. We've got equipment that, as a standard, can do 9 ppm of NOx, and in special cases can go even lower than that. We're driving to utilize green fuels and blue fuels like hydrogen to ever greater extents. And we obviously are looking, as Simon mentioned, the smart grids, the smart optimization systems, what we call the Industry 4.0, as being a key to making sure that we use all the resources as efficiently as we can. Now, in terms of that fuel flexibility, hydrogen is not something that is new to the industry. We've got close to 50 units installed worldwide operating on high hydrogen applications, and over 100 applications where biogas or biomethane waste gas are used. So we've acquired a substantial number of operating hours on these gases. So again, looking for high efficiently combined cycle and cogeneration applications to make sure that we can deliver electricity and heat to the users in the most efficient way possible. Now, To present a typical case for one of our mid-range units, Taurus 60, what you're looking at is a graph of different types of fuels being blended and used inside the equipment. Now that 15% reduction in CO2 is basically the targets that industry is looking at to meet the targets for the future. And as you can see, the various fuels will have different impacts on the type of on the quantity of CO2 emissions that we see. Now, as you can see, the 50% hydrogen in the fuel coming from a green source, so basically wind in a power to gas application, would be the first that starts to make a real dent in the emissions. Anything afterwards, whether it's biomass, biogas, or 100% hydrogen, is where we start to see some fundamental gains in those emissions that we're seeing in the industry. Now, obviously, we have to do this in a reliable and flexible manner for our users, and always looking to operate with the pipeline gases that customers have available to them. Now, in terms of incremental CO2 emissions, so take a case where we're looking at deploying new power generation and new cogeneration applications to take advantage of the electricity and the heat. As you can see, on the left is for the power generation production, and on the right is the steam. Obviously, the least carbon intensive technologies are wind and the photovoltaic and the hydro powers. Obviously, these are not always available to users anywhere in the world. So if we combine these two, we see examples of countries worldwide, and obviously we're using the example of Poland, a country that has heavy reliance on coal power generation and coal-based heat. We see significant opportunities in those countries through applications using natural gas and the blends of green fuels to reduce that carbon footprint. So obviously we see the cases of France, Spain, and Belgium as being relatively low because of the access they had to nuclear power. So we're also talking about not only greenhouse gas emissions, but also the economics behind these projects, and we need to provide solutions in distributed power applications that provide customers with the opportunities to reduce emissions as well as find economic benefits in how they're generating their heat and their power. Obviously, we're talking about diversifying the power source and securing the energy supply to avoid the cases that we saw in London and that we see worldwide, where the more users are on the grid, the more tricky it becomes to manage. And with the advent of renewable technologies, it becomes even more complex. Now, to go straight into our case study or our case example, toilet paper. As Simon aptly mentioned, this is not something that we expected to see become a highly trendy and a run for the money type product in the industry. But the beginning of this year was extremely particular in the sense that we saw a fantastic shortage of toilet paper pretty much on a worldwide basis. So as you'll find different measures of how to calculate the CO2 impact for toilet paper. But this is you can consider this as a general rule. So any toilet paper roll is around 100 grams per roll, and it takes around 90 watts of electrical power and around 200 watts of thermal power to be manufactured. Now, depending on where you are in the world, this can mean between 80 grams to 120 grams of CO2 per roll of toilet paper. And let me reassure you that these numbers we've checked and rechecked, they are even slightly conservative, depending on who you ask in the industry. Now, if you consider that in 2018 alone, we manufactured on a worldwide basis around 380 billion rolls, you can see how using if energy more efficiently, can provide a significant ding in the greenhouse gas emissions. So to take the example of Poland, if we were to consider a standard application where no CHP is considered, we're looking anywhere around 13 million euro per year as a cost, and around 99,000 tons of CO2 being emitted. Now, if we consider a gas turbine CHP, so a standard cogeneration application, we reduce that price to about half, and the emissions are reduced by about 20%. Now, if we consider going the next step in the way of digitalization and making an intelligent use of the resources, in other words, having the power generation equipment connected to the grid and comparing and evaluating constantly what price is the electricity being sold at that day, what price is the gas, when is the most efficient time to generate power locally, or when is it more efficient to take it from the grid, we see an even further reduction in the emissions to about 28% by using the appropriate amount of fuel at the right time and not burning fuel inefficiently at low load or part load applications. And the cost is even further reduced to about 54%. Now, the last case scenario is when we're using high technology renewable applications for CHP. So natural gas is used for steam, and the system is completely connected into the grid. We see the cost being very similar, but the impact into the greenhouse gases, basically the CO2 that we're seeing into the sending out into the atmosphere, is about 2/3 less. So as you can see, we're firm believers, and I think that the numbers themselves are pretty drastic in the ding that we can do to greenhouse gases, while still providing a substantial saving to customers if we consider what the CO2 taxes are going to be and are only going to become higher and higher as time goes by. Now, as a quick conclusion to this, we obviously see the renewables coming into the market as a fantastic potential for reduction in the emissions, but they do provide some challenges in terms of the instability and resiliency of the grid. They do provide significant greenhouse gas reductions, but we also see that in the industrial CHP type applications. We also see secure thermal production that is internal to customer at a substantially lower cost than if it were generated separately. We can also see a transition to the new carbon neutral economy, where we start to use green fuels like hydrogen and biogas. And in the case of distributed power generation, where CHP is used on a gas turbine basis, we take that one step further with the local integration of the grids, whether it's heat, gas, or electric, to provide something that is desperately needed in the grids to maintain that resiliency, to maintain that stability, and that is the rotating mass. As Simon mentioned early on, the electrification of medium and high temperature steam is not particularly cost effective or technologically feasible today. So in summary, this provides a very good economic and sustainable solution to customers in the industry. So thank you, and I hope to receive some questions further ahead.
Thank you, Mark. I suggest we hold off on the questions now and we move right on to our next speaker, and then we will open up the floor, so to speak, to field any questions.
Perfect.
So we'll switch on to our next speaker. She was already introduced at the beginning. Sabrina from Turboden.
Good morning.
Good morning. Or good afternoon.
Oh, good afternoon, yeah. Should I share the presentation?
Yes, please.
Okay. Let me know when you see it.
Perfect.
Okay.
The floor is yours.
Good morning or good afternoon to everybody. I'm Sabrina Santarossa. I'm working in Turboden. I'm sales manager for waste heat recovery application in the industry. So thanks for the possibility to give this presentation in this webinar. And the presentation is focused on green industrial processes benefiting local communities. So we will see some real case of application in the industry together with the local communities. So I will firstly introduce just briefly Turboden and our products. And then focusing about the diversity in the industry, and then move to the real cases, and also talk at the end a little bit about possible application of large heat pump. So Turboden is an Italian company. It was founded back in the 80s by a professor of the Polytechnic of Milan. And since the beginning, the company was focused to design, manufacture, and maintain organic Franklin cycle systems that are highly suitable for distributed generation. In fact, the typical size is going between 500 kilowatt electric up to 20 megawatt electric power. The input to the RC can be biomass, geothermal, and of course, waste heat from industrial processes. Turboden is not only producing ORC. In the last years, we focus and we develop our attention also to other products like gas expander and the largest pumps. Since 2013, the company, the 51% of the company was acquired by Mitsubishi Heavy Industry. So we are now in this big group, the Japanese group, and in particular in the power system, of course. So as said, we have three main products. Of course, the ORC, that is our original and core business product, but also largest pump and gas expander. All these products are designed for decarbonization. They can be employed in projects with the aim to lower carbon emission. So decarbonization in the last years is a word that we have heard many times, and we have seen that there are many policy and efforts to go towards a decarbonized future. We can do this also taking into consideration that we need to consider not only the energy sector or the transport sector, but also the, of course, industrial sectors. So in the industrial processes, some possible answers are reducing emissions, so of course to increase the energy efficiency of the process itself, but also reducing energy consumption from the grid, and this can be done with heat recovery, so recovering the waste heat that is produced by the industrial process. But also a step forward is not only to look at the single industry, but to have a wider look, also looking at the needs of the local communities and also neighboring industrial energy needs. This is showing the experience of Turboden, so the units, mainly ORC units that we have in operation. So we have almost 400 ORC in the world, and more than 30 of these are installed in waste heat recovery projects. So how the ORC is integrated in an industrial process. So we can see that there is an industrial process, like for example, cement production, steel production, or glass production. And all these kind of industrial processes usually has some hot gas or hot water. The hot gas are right now sent into the atmosphere. So we are losing heat, we are wasting it in the atmosphere. We can recover this waste heat and feed an ORC system. The ORC system converts this heat into electricity that can be used by the process itself, or it can be also sold to the grid. On the right side of the slide, you can see several characteristics of an ORC. I would like to focus in particular to the fact that the ORC system is an automatic system, and so the industry can concentrate on its main business, that, for example, could be producing cement or glass or steel, and so they don't have to pay too much attention to the ORC and to the waste heat recovery system. Also, the waste heat recovery system integrates very well inside the process without having any impact on the process. So it is a benefit to have a waste heat recovery system, not only because you are decreasing the consumption of energy that you are using, that you are buying from the grid, but also you don't have any impact on your main process. And so you can concentrate on your main process while having this benefit of reducing your energy bill. Going more into specific cases, I will talk firstly about this plant that is here in Italy, very close to our office. And it is a steel industry, Orimaten. It is in operation since 2016. The process is we are recovering the heat from the electric arc furnace, one of the processes that you can find in the steel industry. So the heat is recovered from the exhaust gas of this furnace, and this gas are heating up saturated steam. The saturated steam is used to produce electricity through an organic Rankine cycle system. We are producing about 2 megawatts of electricity, recovering the heat from the electric arc furnace. But this project is not only producing electricity. This is a wider project where in summer, as said, the steam is used to produce electricity. And this electricity is able to light up 700 houses. While in winter, the steam is sent to the heating district network of the city of Brescia. And the heat that is recovered from the electrical furnace is useful. It can be used to heating up 2,000 houses. So here in Brescia, where is located our company, we have this heating district network, and part of the heat that is used in the heating district network comes from the steel industry of Orimartin. Thanks to this project, we can avoid emission of CO2 of 10,000 tons per year. And just to give you an idea, or to make you feel better what this CO2 emission corresponds, it's like to have or not to have anymore 50 trucks traveling every year for a total of 5 million kilometers. So it's quite a huge quantity of CO2 that we can avoid. Another example, very similar to the one just presented, is a project that is under construction in Switzerland. In this case, the industry is cement production in the city of Eclepen in the French part of Switzerland, where they already had heat recovery since the 1983. And they were already using the waste heat to feed the heating district network of the city. But of course, the heat is not used all along the year. In winter, you need more heat to heat up the houses. But in summer, of course, the requirement of heat is lower. So they decided to further improve the efficiency, the total efficiency of the system, installing an ORC that is fed by the hot water that is not used by the grid, by the heating district network. In this case, the size of the ORC will be smaller, is 1.4 megawatt, and will not produce constantly this electric power. Of course, it will produce more in summer, where the heat is not used by the heating district network, and less in winter, where most of the heat is used by the heating district network. But it's another good example of integration between the industry and the local community. We don't have only example about industry and local communities, but also an example of symbiosis between industries, nearby industries. There is this project in Germany that is in operation since 2013, where again is a heat recovery from electric arc furnace. So we are talking about the steel industry, in particular Stahlwerke Feralpi. And also in this case, there is a heat carrier used to recover the heat is saturated steam. The furnace is bigger, so the electricity produced by the ORC, the power of the ORC is higher, so we can reach 2.7 megawatt. But what is nice of this project is that that 2/3 of the heat that is recovered through this heat exchanger is used to produce electricity, while 1/3 of the heat that is recovered is sold to nearby industry. So near Feralpi, there is Goodyear that is producing tires, and in the process they need saturated steam. So instead of producing, instead of burning some fuel to produce this steam that they need in the process, they are buying from the nearby industry that is producing in a green way, because Feralpi is recovering the heat. And so we have a double benefit, because on Feralpi, they are decreasing their electricity consumption from the grid. And so there is a lower CO2 emitted by the electricity provider. And also they can generate new revenues. And also Goodyear is no longer using energy to produce the steam, and so lowering the CO2 emission of the industry, and also decreasing its energy cost. So this is a good example of how two industries that are close one to each other can take advantage by one of the other. So in one case, we have some waste heat that was not used before this project. In the other industry, we have a two of them. And so this is the example of a win-win situation. As said, Turboden is not producing only ORC. We are producing also large heat pumps that can be employed also in the industry. So, for example, there could be this situation where let's take again the steel industry, but it's not the only industry where there could be some low temperature heat available. But let's take again an electrical furnace where there is not only huge amount of exhaust gas at high temperature. They have also need also to cool the furnace, and so they use hot water to do this. But hot water at usually very low temperature, so 75 degrees, 70 degrees, something in this range. In this range. And so this heat, this hot water that they have available, it must be cooled down. On the other side, we could have district heating networks where they need the heat. But many times the temperatures are available from the industry and the temperatures needed by the district heating networks are not matching. So installing a large heat pump in between these two needs, we can increase the temperature of the hot water available from the steel to the temperature required by the district heating network and to deliver the heat to the district heating networks. Of course, in this case, you need some energy to increase the temperature. And then you can see here that the energy, in this example, the energy required is about 1 megawatt. So the perfect situation would be to do the heat recovery from the exhaust gas of the electrical furnace, and so producing electricity with an ORC. And so part of the electricity of the ORC will be used again in the industry, and part of the electric power produced by the ORC can feed a large heat pump to increase the temperature for the district heating network. So this solution would be beneficial and the perfect situation to maximize the energy efficiency and to maximize the use of heat and power. So to conclude, the valorization of waste heat is possible, and it helps to decarbonize industries and cities. And also it helps to deliver system integration and also industrial symbiosis. So we believe that the excess heat that is available in the industry, and there are a lot of industry where there is available excess heat that is actually wasted, could be one of the main sources for clean heat and power generation. And so also giving a useful decarbonization help to the future. So thanks. Here you have my contact details. If you want to contact me. And then now I'm available also for to answer your questions.
Thank you, Sabrina. Thank you for your presentation. We have some time now to put questions forward to the different speakers, both from Marc Vignal from Solar Turbines, as well as Sabrina Santa Rosa from Turboden. So my colleague Alexandra is also on the line, and she's been collecting different questions that she can now ask to the different speakers.
Thank you, Hans. So we do have a couple of questions. I will start with the more general ones, which can be answered by both speakers. So one question coming from the participants is, in view of the examples shown today, do you consider there's room for CHP in the European Union in the 2030 horizon and beyond? So looking to 2050 as well. And then there's a question also about the economics of energy efficiency solutions running on renewable gases. It's addressed to solar turbines, but perhaps also Sabrina can comment on that. And then a more technical question for Turboden. Are there any developments to higher discharge temperature for heat pumps, for example, towards 40 bars steam, so 250 degrees Celsius? Any of the speakers would like to respond?
Sabrina, I concede to you. Go right ahead. You're on mute.
Oh, sorry. Starting from the last question, we can already provide some steam with the large heat pumps, not 40 bars, but yeah, let's say I would say a little bit lower pressure, so more low medium pressure than 30 bars. If you have any need, we can study also different solutions, or depending if you have heat available from the process, it would be better to use that heat to produce the steam at this high pressure, I believe. Then on the CHP possibility in the future, yes, I think it will be, of course, a beneficial to have and to push for CHP solution in the future, in the 2030 or whatever in the future. Of course, supposing that climate change will not be as high as becoming a tropical weather. In that case, we will need cold, not heat. And then the second question was related to the to some investment. If I'm not mistaken.
Yes, the economics of CHP running on renewables, given the very low oil prices in the current COVID crisis.
Yeah. Answering about ORC, so not for solar turbines. I mean, it depends. The investment costs are not the same for all the application. So if we are talking about CHP based on biomass, it has a different investment compared to a CHP based on waste heat recovery. But in general, for example, when you have biomass, there are some incentives also to have this CHP based on biomass, or for some customers the biomass is available at zero, like in sawmills or other process where they are processing the biomass. They have available waste biomass at zero cost. In that case, of course, it has a good economic feasibility. In case of waste heat recovery, you are not burning any fuel to recover the heat. You are recovering something that you have already there. So it has not a competition with the CHP based on the traditional fuels. But I think also solar has something to say about this.
Indeed. Thank you, Sabrina. And I concur with what you've said. And I'd like to start with the more generic of the questions regarding the applicability of CHP in the European Union. And clearly, we see a substantial benefit in the 2030 horizon and beyond. I mean, the deployment of hydrogen and green fuels is clear, and it is a direction that the EU Commission is taking. It is the direction that that a lot of countries around the world are focusing on right now. We strongly believe that the gaseous fuels and rotating mass on the grids is going to be present for a long time to come. We need to have stable grids to operate most of our equipment, and that needs to have some balance and probably a very good mix of different energy providing technologies into the grid. So we're not in opposition of working with different fuels, and I would say that this is one of the greatest challenges that we have, just being able to cater to the needs of customers depending on their different applications. So to put a little bit more context in that, if we look at coke oven gas applications in China, for example, where we have a substantial number of units, we operate anywhere between 60 and 70% hydrogen on those units. But the challenge is always with what comes in addition to that 60-70% hydrogen. It can sometimes be contaminants, it can sometimes be heavy hydrocarbons, and it greatly depends on the various applications. But we definitely see a benefit in terms of flexibility and in terms of the integration or sectoral integration of the industry by allowing different markets to work together. So as Sabrina's examples clearly showed, utilizing the waste heat from one factory as heating for the city, or as the main source of energy for a neighboring industry it's just good technical sense, good engineering sense. Now when it comes to economics and the cost of energy nowadays, you might argue that the barrel of oil being so cheap would be a hindrance, but I think we all know that that's not where the world wants to focus on. So we need to focus on good economic solutions and sustainable solutions. Now, I see another question, if I may, Hans, just to take the microphone for a couple of more minutes. There's a question regarding the applicability of, or when we'll be ready to burn 100% hydrogen. Let me be slightly cryptic in the response by saying that we'll be ready when the industry calls for it. For the time being, we're being pushed to be able to burn up to about 20% hydrogen in blended into the natural gas in standard applications in Europe. We can already go up to about 65-70% in conventional combustion applications, in like coke oven plants and waste plants. But we'll be ready when the industry starts to supply us with the projects for 100% hydrogen as a fuel. And I think most of my colleagues in the gas turbine manufacturing industry would agree. We're working towards that end, and we'll be ready when the projects start to come.
Thank you, Mark.
I see that there are some additional questions coming in. Let's see. So 2 questions for Sabrina. What are the main barriers for heat cascading to be used more widely? So from industry to district heating, for instance. What is necessary to enable wider utilization of waste heat in district heating? What are the success factors in the example you presented?
Okay. So firstly, not all the industries has close to them heating district network. So first of all, we should focus on industry where they have nearby a heating district network. And in the example I presented, especially in the first case, for example, the steel industry is inside the city, basically, because the city has grown around it. And so they wanted not only to have a waste heat recovery because of short payback time. They wanted also to have it because they have to live together with the community that is around them. So they want to have a good relationship with their with the neighboring. And so they were not looking only at a payback time or the typical payback time of an industry that is 2-3 years. These kind of projects, I will tell you, without any incentive, they cannot have this very short payback time. The heat recovery project payback time is more around 4, 5, 6 years, or even higher in some cases. And so it's not only looking at economics of the project, but also at sustainability and also benefiting the community, not only the industry, but also what is around you, also to have a good green image, to be more accepted by the community, by the city you are living close to. So these were also important points that were considered by the industry before doing this investment.
Okay, thank you, Sabrina. And very last few questions for Mark. This is a theoretical question on, let's assume we have Ireland, an island market with windy days where wholesale electricity prices are very low and even negative. Would electrification of heat be a sustainable solution for to capitalize on those high wind periods?
Well, I would say that one of the greatest benefits of wind energy is that it's there, and if it's there, we should utilize it as much as possible. But the fact of the matter is that it's variable. And that provides an interesting challenge, because what happens when you need the heat but you don't have the electric power to generate it? So in those cases, I would definitely say that yes, it becomes a little bit more cost effective based on smaller sizes. We certainly don't manufacture that type of equipment, so I'm probably not the best equipped to respond. But I would say that from a sustainability perspective, clearly, if the access to wind power is there, it's going to be necessary to take advantage of it and make sure that we rationalize it in terms of cost.
Thank you, Mark. One final question. It has to do with CO2 neutral Poland and the scenarios that solar turbine presented.
Mm-hmm.
The question is, what were your assumptions about the investments, and how would you make such a project economic? Would you need incentives and a policy framework that supports such a pathway?
Okay. Well, clearly having incentives or country incentives like what we see, for example, in Italy right now, makes a CHP application very, very interesting, because the payback on the project is substantially shortened. Typically, we see customers doing the calculations, and anywhere between 7 and 8 years is already feasible. But with the right incentives, taxing CO2 or providing further incentives for certain type of applications like CHP, it becomes economically very, very feasible. Now, it's absolutely correct. If there are no financial incentives from the member state or the country to go in that direction, the payback period is probably going to be a little bit longer. But the bottom line is that we're looking, and that specific example was a 16.5 megawatt unit that is also generating about 30 tons of steam per hour. And we were looking anywhere between 12 and 13 million euros as an investment for traditional means. So coal-based fire, and traditional steam, a boiler, standard boilers. Now, when we compare that to the investment required for a gas turbine system operating on CHP, that's where we see the economic benefits. Absolutely.
Okay. Thank you, Mark and Sabrina. There are quite a few other questions in the chat function that we haven't been able to get to due to the lack of time. But I invite the speakers to take a look at there, and in some cases, people have left their emails, so feel free to catch up with them. As I mentioned before at the beginning of the webinar, we will try to make these presentations available if the speakers agree on the website of the webinar series, and we'll also try to make the recording available. So just wrapping up this session now, I'm going to give the floor to my colleague François Paquet to give some concluding remarks on what was just said, and also taking a perspective of what's being discussed.
Okay, I assume you can see my screens now. Is that correct?
Yes, François. Go ahead.
So assuming you can hear me, thank you very much for the speakers today and for presenting those very concrete elements of what is a successful story in industry and how this can concretely help industrial players to decarbonize and bring what we call a more circular economy from the energy sector perspective by using energy flows in a better way. What we certainly heard today is that heat is a central element of industrial life. Heat is key for running the production lines every single day of the week, and also to minimize production costs. So this is a key element of the European industry's competitiveness, also facing global competition from other areas of the world. So what we heard today was really the question of ensuring this heat supply security at all times to preserve the competitiveness of Europe. A second key element that we heard, judging by the presentation made, is the question of heat, which is also an important factor of CO2 emissions in Europe. And that's a quite big challenge when we look at industry, because there is a huge amount of heat and also power, but let's focus on heat, that today in industry is being wasted. That comes from polluting and inefficient sources. So when we look at the trajectory for decarbonizing Europe, we need to tackle those wastes. We also heard that certain types of heat, medium and high temperature heat, steam, can hardly be electrified for cost and technical reasons. Looking at the presentation, we see that there will be a need for molecule-based heat in the future. So the point I'm trying to make here is that we see that we have specific needs in industry, which are very likely going to be different from a typical household or district when it comes to heat demand and how we decarbonize it. So the point I'm trying to make here is that without a clear approach for decarbonizing heat in industry, but also in other areas of the economy, we will not decarbonize Europe. That's the first key point, I think, that needs to be made. And this decarbonization pathway needs to be done cost effectively for preserving that competitiveness in Europe. Now, thankfully, we do have the technologies which are there, as we heard today, offering a complementarity of technologies and solutions to foster an efficient and clean electrification within industry, together with a secure heat supply. And that's a very important point. And one key solution that is being there is cogeneration, as we heard. At Cogen Europe, we see the benefits of cogeneration. And talking about the economics, this is probably, as Simon mentioned at the very beginning, one of the very few solutions that allows to hit three birds with one stone. When you are an industrial players, you try to reduce your energy bills, you try to reduce your environmental footprint, and at the same time secure energy supply. And CHP or cogeneration is one of the few solutions that allows you to do all these three things with one single investment, maximizing therefore the return on investment. And that's a very important thing. For those benefits, cogeneration is supported by the EU legislation, in the Renewable Energy Directive, in the Energy Efficiency Directive, in electricity rules, and this piece of legislation is very important to support this solution that is playing on several markets at the same time: gas, heat, and electricity. Talking of the benefits as well, cogeneration, when we look at the 2030 framework, since we talked about it, we see that there is a cost effective potential for cogeneration to develop in the future based on EU-funded project Code 2. Currently, cogeneration in Europe delivers 11% of electricity in Europe and 16.5% of the heat used in Europe. But towards 2030, we see that potential increasing with the right policy measures and support, up to 20% for electricity and 25% of heat being generated in Europe. This is not insignificant, because with that additional generation by efficient solution like cogeneration, we could deliver more than 1/3 of the future CO2 reduction targets to be set between 50 and 55%, depending on the negotiations in Europe. There will be also a huge contribution for the energy efficiency targets in 2030, measured around 18-20%. So these figures are quite significant, and the potential of cogeneration is there, should it be, if we want to support it in the right way. A key element that we see importance from the point of view of cogeneration is that this energy today can no longer be wasted, and we need to set high efficiency cogeneration as a default option in industry and SMEs producing heat at high level temperature. All this to do more with less. So cogeneration should become the default option over the separate, less efficient, more polluting production of heat or power. And all this to do more with less, to modernize and improve the energy efficiency and environmental performance of existing industrial processes. And that's ultimately going to reflect on the environmental footprint of the products we consume every day in Europe. This should help really deliver significant CO2 reductions already today, and that's all the CO2 we don't have to remove from the atmosphere tomorrow. Making links with the current files being discussed at European level today, the Just Transition Fund should really look into this, at transforming and modernize carbon-intensive regions and industries. and looking at solutions like cogeneration should be part of this focus. But cogeneration can do more, as we heard today, and that's about building the industry of tomorrow, delivering smart system integration by integrating locally the heat, gas, and electricity networks, and by ensuring the best conversions between them to avoid wasting valuable energy. Delivering also resource efficiency and industrial symbiosis by optimizing the flows of energy, but also ensuring the cascade use of energy, delivering secure and affordable heat to neighboring industries and local communities. So quite important elements to realize the circular economy goals. The dimension of system flexibility was also mentioned, where cogeneration really helps to supply efficient, clean, flexible electricity to the grids, but also when the electricity is consumed on site, allows to reduce the pressure on electricity grid from peak demand when we know we don't have enough intermittent renewables, for example, in winter. With those services, of course, industrial producers can generate new revenues. There is also an element that is absolutely important when we talk about flexibility, the reduction of pressure on the grids, reduction in capacity reserve needs, reduction on electricity grid reinforcement. So the overall system cost on top of the better economics for industrial players is also improved. Last but not least, we heard a lot about renewable energy sources today, and this is a key element that needs to be stressed. Technologies are being developed, technologies are getting to be ready. We need clarity on the deployment of renewable and decarbonized gases, accompanied with support measures to support that decarbonization process. And one key dimension here is also making sure that we use those fuels of the future in the most efficient solutions for cost-saving purposes, because they will remain somehow expensive in the near future, but also to avoid wasting them, because their availability will be limited, and we need to have all possible quantities also for decarbonizing other sectors. Without any further addition, I will pass on the floor to Hans, who will introduce the next webinar.
Thank you, Francois. Before I do that, I'd like to just take the opportunity to sort of virtually clap and congratulate both of our guest speakers this afternoon. So a virtual clap to Marc and to Sabrina for their contribution. Thank you for taking the time to prepare the slides and for joining us to talk about your different companies and technologies. Much appreciated. As I mentioned to all the participants in today's webinar, we will make everything available on the website. Having said that, it is my great pleasure to announce the next edition of the Power and Heat Boost, which will focus on local energy system integration. That'll take place on the 19th, same time as now, between 1 and 2:15. We have already three confirmed guest speakers. We have someone from Veolia to give some introductory remarks, and then we have someone from INEO Janbacher, who will present the Kiel project in Germany, looking at integrating flexible power and efficient district heating. And then the second case study that will be presented by GRDF, so Gas Réseau Distribution France. It's looking at the Nice Smart Valley, integrated distributed energy for the Côte d'Azur. That will all be happening again on the 19th of May, and we will launch registration either tomorrow or the next day at the very latest. So thank you everyone for participating in our first inaugural webinar as part of our Power and Heat Boost series. Apologies for the minor technical glitches at the beginning. We're also learning by doing, and we're just very happy that you took the time to join us from your kitchens, your living rooms, your offices at home. So I wish you all a good day. Stay safe, stay healthy, and hopefully we can reconnect at our next edition in May, if not in the future. So thank you on behalf of Cogen Europe and the team. Have a nice day.
Thank you.
Thank you.